Alright, another example of factoring out the greatest common factor, GCF. I'll try to keep this video short, but no guarantee, okay? Because I like to go into detail about doing this type of problems. And of course, it's because, in my previous years of teaching math, I have a lot of students who ask me about factoring because they have a lot of trouble with it. So I like to go over it in details, but not too long. Okay, I'll try to keep it shorter than my previous examples. But anyway, let's start it out. So we have this expression here. So let's see, I want to go with the short way that requires mental math. So for the coefficients 52, 39, and negative 65, can I factor out the smallest coefficient, 39? Well, I know that 39 is a multiplicative factor of itself, but not of 52 and not of negative 65. So there's no way I can just factor out the smallest coefficient, positive 39. But what if I try to find out whether or not there is a common multiplicative factors of the coefficient 39, 52, and negative 65? Well, let's see. I know that 39 is the same as 13 times 3. Okay. So what about 52? Well, 52 is the same as 13 times 4. Correct? I mean, let's see. 4 times 3 is 12. Right, 2 keep 1. 4 times 1 is 4. Plus 1 is 5. So 52. And negative 65, well, negative 65 is the same as saying positive 13 times negative 5. Yeah. So guess what? We have 13 as the common multiplicative factor of all of these coefficients, okay? So we bring the 13 out to the front. What about the x and the y that goes with all of these three coefficients? Hey, in the previous examples, I said that whenever you factor out a common variable, you factor out the one with the lowest exponential power. So for the x, you have x to the fourth, you have x to the fifth, and x to the second. So we factor out x to the second. And of course, same thing for the y. Okay, let's see it there. You got y to the third, y to the second, and y to the seventh. So we factor out y to the second. And what about the leftover? Well, the leftover is going to be what? Well, we know the leftover, the first term is going to be the 4. After factoring out x squared from here, we're left with just x to the second. And that is true because if we were to distribute the x squared back in, we would have x squared multiplying x squared, which is the same as x raised to the 2 plus 2, which is x raised to the 4th. And of course, same thing for the y. After we factor out the y squared from here, from the y to the third, we're left with just y, or y to the first. I'll write it just to be clear. What about the second term? Well, the second term we're left with positive 3. Factoring out the x squared from x to the fifth, we're left with just x to the third. Factoring out the x squared from here, well, we got nothing left over for the second term. Now, what about the third term? Well, we know that we have negative 5 left over, so minus 5. Factoring out the x squared from here, well, that whole thing is gone. Factoring out the y squared from y to the 7, we're left with just y to the 5th. All right, so that's a short way of doing it. And of course, if you guys were to distribute this whole thing back in, you will see that it's going to give us back the original expression, okay? What about the long way? Well, the long way is similar, but just longer. But the way we approach it is still the same. Meaning we have to break down each term into its respective prime number, multiplicative factors. So let's go with the first term. Let's see, 52. Well, we know 52. It is up here. It's the same as 13 times 4. X to the 4, just x multiplying itself 4 times. And then y just multiplying itself 3 times. Actually, I'm going to write it like this. My bad. So as mentioned, $52 is the same as 13 times 4. So 13 times 4. And then x to the 4, just x multiplying itself 4 times. And then y to the 3 is y multiplying itself 3 times. Now everything in here except for positive 4 is a prime factor. Okay, so positive 4 is a composite number, so there are two smaller numbers that multiply together to give us back positive 4. And those two smaller numbers, which also happen to be prime numbers, are positive 2. So we'll bring down to 13. And then 4 the same as 2 times 2. I'm going to bring down everything else. Now let's do the same thing for the second term. So the second term is 39 x to the 5th y squared equal, well, up here we know 39 is 13 times 3. 13 is a prime number and 3 is also a prime number. So hey, we're good there. So 13 times 3, x to the 5th is just x multiplying itself 5 times. And then y squared, just y multiplies itself 2 times. For the third term, negative 65x squared y 7. So minus 65x squared y 7. You guys see it there? Yeah. Well, negative 65 as above is positive 13 times negative 5, but negative 5 is the same as negative 1 times positive 5. So that means we have 13 times negative 1 times positive 5. X to the second is just x multiplying itself 2 times. Y to the 7th, y multiplying itself 7 times. Okay, so we have one list of prime number multiplicative factors, second one and third one. Well, let's collect all of the common parts of the greatest common factor. Let's start with positive 13 in the first list. Well, we get positive 13 in the first, in the second, and in the third. So that's one thing. Positive 2, we got positive 2 in the third. I mean in the first, but not in the second or in the third. So not positive 2. Same thing right here. It's in the first, but not in the second or third. What about the x? Well, we got x in here, x in here, x in here. So 1, 2, and 3. What about the next x? Well, 1x, another one, and another one. You can see it. What about the next one? Well, we got x in here, but not in here. So this is out. Same thing for these two. And of course, same thing for this x, okay? Because this x is in the second, but not in the first or the third. What about the y? Well, we got one y in here, one y in here, and in here. That's another one. What about the next y? We got one in here, right there, right there. What about the next y? Well, you got one y in here, but we don't have any more in the second. So that means this y is not part of the greatest common factor. And we run out of terms in the first list. So that means we have nothing else to consider for the greatest common factor. So that means all of the common parts of the greatest common factor is 13 multiplying x multiplying x. And of course multiplying is y too, my bad. So 13 times x times y times y. So we just have to bring it outside. So we're going to write 13 times x times y times y multiplied all of the leftovers. So the leftovers of the first term is 2 times 2 times x times y. For the second term, the leftover is positive 3 times x 3 times. For the third terms, we have negative 1 times 5, and then times y 5 times. So plus negative 1 times 5 times y times y times y. There we go. 13 times x 2 times y 2 times. That's 13x squared, y squared. 2 times 2 is positive 4, x times x squared, and then y, so 4 x squared y. 3 times x 3 times, so that's plus 3 times x raised to the third power. Negative 1 times y is negative 5, y multiplying itself 5 times, so y to the fifth. So minus 5 y to the fifth. Hey, guess what? For the long way, we get the same answers as the short way up here. So you see? So earlier we did the short way, and you see it requires mental math. But you know, once you continue to practice more and more, you eventually get a hang of the short way. Okay, and once you get a hang of the short way, trust me, it's going to save you a lot of times on the test or the quiz. So yeah, make sure you guys get used to the short way in addition to doing it the long way like I did down here, and you still get the same result no matter what. All right, you guys, thank you for watching. See you guys next time.